9.2 notes where I left off. This is the last page I showed you in the other notes, but this gives me an opportunity to just talk a little bit more about your types of errors that you can have, your type 1 and your type 2 error so let's go to the next page, page 9, about a practical example of using a test about a population proportion. So we've got this potato chip producer, and they just received a truckload of potatoes from their supplier, and they said that they're going to reject these potatoes if more than 8% have blemishes. We go out and we take a sample from the truck. We find that 47 of the potatoes have blemishes out of a sample of 500. So a lot easier to identify what the sample statistic is in this situation, because it's basically the result of what you had when you went out and did your sample. So I've got my sample value right here, and make sure you're defining what you are. The P is going to be the proportion of bad potatoes in the truck. Well, I guess blemished potatoes. And so that informs you what the parameter is, because it's the other number in the problem, the 0.08, and that's what you're going to be looking at for it to be more at the alpha equals 0.10 level. Of course, check your conditions for inference. If it's random, got to be watching for bias in that sort of situation. No bias there. It's given it was a random, simple random sample. Independent. So that I'll be able to do calculations for my standard deviation of my sampling distribution. 500 potatoes is less than or equal to 10%. And we're going to have to use that check because we have a finite number of potatoes in that truck. And so this is only going to be valid if n is greater than or equal to 5,000 potatoes. That's going to fulfill the... Okay, is it nearly normal? N times P has to be greater than or equal to 10, N times Q greater than or equal to 10. So as I check I'm using my population values here, not the hats. If I see that my 0.08 is going to fulfill it, then of course the 0.92 will. So I find that 40 potatoes is greater than or equal to 10. So that's fulfilling that. The conditions are met. Conditions for inference. So I identify what I'm doing. One sample, Z interval for a proportion. Okay, great. All that just to set it up, and now we can actually do our test. So here's my curve. I'm going out there thinking that this is 0.08. I went out there and saw my number with more than 0.08 being blemished. I'm looking at this because this is going to be my region where I'm going to reject the null hypothesis and decide that I'm got too many potatoes that are blemished at the 0.10 level. Alpha equals 0.10. All right, my null hypothesis in this situation, remember, it's parameters for tests. So my P equal to 0.08 because the null is going to be a condition of equality. The alternative in this situation, doing a one-tailed test, only looking for those bad potatoes, looking for that going over 0.08. But is this statistically significant? Well, we're going to need this standard deviation of our sampling distribution using parameter values, because we're assuming that that parameter is true. So we're going to be using the parameter because that's what we think is the truth. And so we put that number in to find our test statistic, and So the sample statistic minus the parameter divided by the standard deviation of the sampling distribution. And we're going to have a test statistic that we can then check on that curve and see if that value is statistically significant. There's our value. This is the Z value at this location right here. And we're going to test that. So writing my notation of looking for that Z going above that value of 1.1539, and I get a p-value, probability p-value of 0.124. So since the p-value of 0.124 is, what is it? Is it greater than, less than? Oh, it's greater than alpha equal 0.10. We fail to reject. We're keeping those potatoes. Fail to reject the null hypothesis. And there is not significant evidence that the proportion of blemished potatoes is over 0.08. So we keep the potatoes. Now, we may be wrong about this, and because we are failing to reject, when you're wrong and you've failed to reject, you've committed type 2 error. But the question over here says, what if this was a type 1 error, which we don't have type 1 error. What's type 1 error? It would be when you reject the null when you should not have rejected the null. So let's describe that in this situation in context. If the potatoes were good, but we rejected them, we rejected them, then got to be in context. We would have sent away perfectly good potatoes. Good potatoes. Our supplier would not be happy. And the probability of that happening, that happens to be the same as our alpha 0.10. That's for the situation at hand. That's your type 1 error in this situation. But let's say the truck really does have more than 8% blemishes. In fact, the truck really does have 11% blemishes. So let's think about what that would mean. What would type 2 error be in this situation? Type 2 error would be when the truck really has those bad potatoes, really has over 8% blemishes on its potatoes, but we keep the load of potatoes, and we just made chips from the potatoes. That's going to be a worse situation from the standpoint of the manufacturer, because then they just made a product out of bad potatoes that, potentially could make their customers upset. But what's the probability of this happening? So here's my curve with my potatoes here, what we would like it to be true, that being that blemish level or less. But in fact, we've got this other curve showing, these alien potatoes that are really different. They're at 0.11. They're really not the same as our potatoes that we have. And then we just went out there and we got a statistic of 0.094, which doesn't really matter for this calculation of our power and of our type 2 error. What really matters is, here's my type 1 error. My type 1 error it's around here, because I know what the value is for this line that I'm drawing right here. I know what that value is, so I know I can draw it right there. Here's that type 1 error right here, and its area was 10%, 0.10. There's a value that cuts that spot off. If you're on the left of it, you're keeping the truck. If you're on the right of it, you are not keeping the truck. So let's find out what that value would be. Okay, so at that value, I'm just going to write some calculator speak so that you can see what would you be doing. Well, you need this area on this side of this line. Well, that's 90%, because that's 10% was alpha, 90% would be the other side, so 0.90. You said now we've got to put in the mean, and we've got to put in the standard deviation. So the mean for this situation is 0.08, because we're on that curve, and the standard deviation of the sampling distribution from the other page, it was 0.012136. So based on that information, I can get this line that's cutting off our two sides, 0.095545. So you can see why this line here, that was our sampling value, which chance variation, every time you go out there, you get a different number. That value was on the left side. It's in the keep side of the curve. But now that we know what this line is, I can say, well, what's my power of catching these bad potatoes? This is my, or actually, sorry, this is not my catching them. This is my type 2 error area. What's my probability that I'm keeping these potatoes, but really I'm on this bad guy curve and I need to be rejecting them? This is going to be my probability of type 2. So I have to find out what that is. I'm thinking in terms of the green curve. And so let's see, I'll use calculator speak. And so go way down, because I don't want that to affect anything, but I want to use that number that I just found. And I want to now think, oh, wait, I'm on the green mean and standard deviation. I need the green curves values for that. So 0.11, and just because, hey, I don't feel like finding the number, I'll just put it in with the formula here. Maybe raise it to the 0.5 to take the square root. And I put that thing in there, and I find that this probability of that green error, which is my type 2 error, is 0.151. There's a relationship between that type 2 error and the power. The power, all of this area, all of this that you can see, well, let me move it up a smidge. All of this This is my power. See, I'm in my green curve, and all of this is my power of having caught these guys, caught these bad potatoes that they're trying to make me accept and make into chips. But let's see what's my power of catching them as they do that. That red thing, my power, there's a relationship. It's 1 minus beta. Remember, this is beta right here, our probability of our type 2 error. So 1 minus 0.151, and my power of having caught a load that they tried to sneak that in on me, 11% bad potatoes, blemished potatoes. That's my power of catching them. So, well, we'll talk to you later. Bye.